All right, everyone. Welcome to September 10th, 2025 meeting of SIG-Auth. Reminder that this meeting is recorded and please be cordial to each other. So let's take a look at the agenda. I don't think we have anything in announcements or full notes, so let's just jump into the discussion topic. Ahmed, are you on the call? Oh, it's not here.
Yeah.
Sorry.
Yeah.
Yeah.
So yeah, I think we just need to make a decision on for bringing pod certificate volumes to beta. Do we want to support some sort of inline key value pair mechanism or additional configuration that the user can put in the volume spec that then gets forwarded into the pod certificate request and then is available to the signer? So the sort of use case this would be for would be things like if we wanted to ship a signer that issues certificates for service DNS names. I've implemented a proof of concept of that, but right now it just kind of like maintains I think it has to maintain a graph anyways, but like it maintains a graph of like what mapping from pod to all the current service DNS names that they are covered by. If we wanted to give the pod spec author a way to hint that they only want this service or that service to be included, then we need a way for them to pass that information. The kind of two reasonable options are they could put it in a pod spec, and then the signer implementation could go fetch the pod, take the annotation they care about out of the pod spec, and then proceed to process and issue the certificate. Or we can put that information inline in the volume spec. I don't have a strong opinion. I was originally planning to include key value pairs in that volume spec, but concerns from David and Jordan were that the similar mechanism for CSI drivers had led to some security problems because CSI driver implementers didn't always understand or reason through that it was just the user setting those key value pairs and they weren't validated in any way. But it seems like that's a general problem, even if there were annotations, except that annotations might look a little more untrustworthy in people's minds.
Yeah, if the thing is going and looking up information from the pod, it's a little clearer. Like, oh, whoever wrote the pod had control over this field. If the data is in like key value pairs and that gets propagated other places, and then the places it gets propagated to might not have a clear understanding of who had control over that data. And so I think that was part of the problem with the CSI stuff. Like the user could put arbitrary parameters in a volume spec, and then the driver would take those arbitrary values and like merge them in with other things pulled from cluster level configuration and then pass it all to the CSI driver. Be like, here's parameters for you. And so the CSI drivers were like, I don't know, I guess these are my parameters. And some of the parameters could be like terrifying things, like set this kernel option or set this mount. Like,
oh, so there was some like munging that happened partway. Okay.
Yeah. So the CSI drivers don't call back out to Cube API, at least not in gen. Like the CSI stuff is designed so that there's a central controller or the kubelet is like doing stuff like accumulating information from the Cube API and then calling out to a driver over gRPC. And so the driver was like, I don't know where these parameters came from, but I guess it's cool for me to like let them do scary things.
So I would say we have an internally implemented equivalent of pod certificates built on CSI drivers, and we use that key value mechanism to pass like certificate hints in our implementation. we never thought it was a security concern because it's like an ephemeral driver, so there's no central component. It's just like directly like when I was doing that, it didn't even occur to me that there could be a security problem because those were obviously untrusted values.
Yeah, if if people treat them as obviously untrusted values and it's like compare them to what is allowed or permitted or validated, then
Yeah.
the plumbing I don't have strong opinions about. Like map string is like whatever, it's fine. It's the simplest thing that could flexibly accommodate a lot of stuff.
I don't think it's fine, Jordan. I've seen what people do with it in CSI. It is not fine to shove YAML into a string and call it fine.
Yeah, so you want a opaque extension, which I think is reasonable, like a fine approach.
If we did it for DRA, I don't know why we wouldn't do it here. It's not like DRA is old. But the one thing I do want to point out specifically about CSI though is they have abused that parameters field for things that do not make sense in belonging there. Right? In particular, they put tokens in there, which have no business being present there. They should have made a separate field and given it a separate channel, but they got a little too cute and clever with what they shove in there, right? And like the second you have to start string namespacing your keys to include like the stuff that's trusted and the stuff that's not trusted is insane, and you shouldn't do that. Right. So like I'm not like particularly perturbed by CSI drivers went crazy. Is because the API is garbage and you shouldn't have done it that way. Uh like
I think having an opaque extension kind of pushes against that a little bit because then it's like we can't put arbitrary like kubernetes.io stuff in there. It's like it's
we
whatever
would
the
never, why would we use that extension? We
yeah.
would use first class fields, right? Like I'm fine if the field is called untrusted, do not ever like be like don't use for security stuff. Like David, go for it. You got your
So I was gonna try to be sure I had followed correctly where we had evolved to, right? So I think we all have learned from CSI drivers you never mix trusted and untrusted data, right? Because for CSI drivers, some of those parameters are indeed trusted. Cluster admin set them. Cluster admin is the only one that can control them. And by the time we got to the CSI driver, we were simply unable to distinguish what was what. So I think we all agree we don't want to do that. So now we're looking at trusted values and untrusted values. Right. And I'm not excited about an idea of having raw extension for just a full set of untrusted things. I think that will encourage the creation of like entire languages getting embedded in there.
Okay,
And
okay, we can drop the raw extension. Fine, map of string to string, like
a map.
What's the data flow? Like that's what I'm not sure of. Are we saying these parameters live in the volume spec in the pod, and how do they get sent to the signer?
Through the pod certificate request body, Kubelet will put them in the body, and then they'll pass through Kubelet server, but be untouched. Like Kubelet server does nothing to them.
and the field should have the word untrusted, I guess, in it, just to make it annoying and obvious.
Or user requests or something.
Pod user like it should be clear that this came from the pod, and we should never mix other things into that and use it as a single channel to merge other stuff. As long as the data flow is clear and it's clear that these came from the pod and we never try to mix other things in, like at that point, you're talking about plumbing data to the signer. People are creative. If we don't give them away, they'll find a way. And if we give them away, some people will use it for not recommendable things, and there's not a lot we can do about it. What we can do is keep like the user stuff separate from the not user stuff.
Yeah.
What I don't want to get into is every single signer has to watch every single pod on the cluster, because that's insane. Right? Because there's no field.
So the service signer is gonna have to watch.
I'm not worried about the ones in KCM. Like we have the garbage collector watching everything. That's not the issue. I'm talking about like if you have 30 of these on your cluster now, because everyone goes and makes one, and all of them are watching all pods on the cluster. It's not. I don't think that's the state we want to end up in, right? Like you should be able to reasonably like build a signer without having like read access to everything. David.
So let's imagine we do create something that says, "Hey, I want these services for my pod." If I'm thinking through the flow of that correctly, what actually has to happen in that case is whatever's processing the request is going to know which pod it is. It's going to know a request for these particular services, and then that thing is going to have to inspect the services in that namespace and the pod itself to make a determination of whether it makes sense to allow this or not. And so no matter what path we go down, I think, Mo, we are either doing live gets or caching all the things. Am I misunderstanding?
For the service one, yes, because there's like a security property that the service signer has to enforce. It needs to maintain a graph or a database of like what services cover what pods. But like I can think of many internal use cases I have where it would be very nice for me to specify like a spiffy trust domain or a project or whatever when I mount the cert, and the signer is going to do some other stuff with that information.
And
And
you
it,
don't
it
think
would
that the
let me
signer
not,
is going to have to verify that information, or you
but
think the
not
signer will?
but not by listing out all pods. It doesn't care about
Okay.
the pod. It cares about some other, like
Okay.
it'll call some GCP APIs to.
Okay.
So like for me, I would like this mechanism because I think it would let my signer implementations that I'm thinking about not list all pods or not watch all pods.
Or do live gets. None of which
Yeah.
is great.
Okay.
Yeah. I
But
think
I'm
that's
not like, it's not like a firm requirement for me. Like I could make it work without it.
It does mean that if we don't have it, then we basically tell people to just come up with whatever API they want to come up with for how they fetch the information, whether it's pod annotation, some random custom resource, or whatever.
Parity with volume attributes as a simple map string, so we don't give people enough rope to build entire cities off of, to mix metaphors, which we then plumb down to pod certificates. Makes it possible to like flow the data from the user to the pod certificate to the signer without them having to have read access on all pods and like look up stuff and do side channel stuff and pod annotations. That doesn't bother me. Does that seem plausible? As long as we're super clear about where the data came from. And if we have a thing in the future where we're like, we have cluster scoped options we want to provide, like we're gonna have a separate field for the cluster scoped options that an admin set. Yeah.
The only thing I can think of is, do we want map string or do we want like a bytes of JSON or?
What is a bytes of JSON?
Well, like, do we want? I guess that's the same as an opaque extension, but like,
I like encouraging simplicity with string, because I think it encourages people to decompose what they're looking at.
Do we want to go further and force them to namespace their stringies for the keys, like we do for user extra? Or are we okay not having it? I don't know.
If the keys have to be qualified names, that doesn't bother me. That makes people think about domain ownership. That, sure.
I agree.
Okay, that's fine. I had a related question to all of this that I wasn't sure if it made sense, but I wanted to ask it in this same conversation because it's related. Is so to here today, you can create one of these pod volumes, assuming you turn on all the features and everything and have new enough everything and use it. And it is up to the signer to sort of decide, if it's going to honor that or not. Is there any desire or value in attaching an authorization check to the use of a particular signer in a pod volume? Right. So in order to sign the pod certificate itself, you have to be able to have the right auth. So obviously the signer needs a particular amount of authorization to do those checks. Should a pod itself, like the service account of the pod, need any particular authorization before it's allowed to even use the signer to begin with?
I never thought about that.
I didn't
When I
make
think about it, I think it's the signer's responsibility to decide if it wants to be giving this pod a cert or not. But anybody can show up and ask for it.
Is the concern like that you could make a lot of CSRs be created, or that the existence of a CSR would be problematic in some way?
I don't know if I had a specific current concern as much as if we don't have it today, we can't add it later because it wouldn't really make any kind of backwards compatibility sense. And I was trying to think of like if I'm a cluster operator, what do I like? Am I okay for every pod to be able to ask at all? Like, or do I want stronger controls about who can ask and what does that look like?
The pods started gaining the ability to make objects be created with like ephemeral volumes and resource claim templates. I there may be some quota things around that, but they're not authorization checks. So like you can have a deployment with a replica set that spits out a bunch of replicas that says, I want everyone to make a resource claim be created, and an ephemeral volume which spawns a PVC object, and like you can do that today. I guess you could limit those things. Resource claims and PVCs are in the namespace, so you could use resource quota to limit how many of them could be created. The PVCs, or sorry, not the PVCs, the CSRs that will. Oh, this creates pod certificates. So you could also use resource quota the same way to like say you can only have this many in this namespace. So you could have sort of DOS boundaries on blast radius the same way you could bound runaway namespaces for those other things. I don't know. That quota and like how many objects could you make be created are the main things I would think about.
So think about, so if you have a in-cluster signer that does some in-cluster functionality, right? One way for that signer to be modeled is before it decides to sign you a certificate, it could try to perform like an authorization check on the service account that was in the pod certificate to say, hey, is it allowed to use me or whatever, right? And I was trying to think like, would it be bad if we just did that always? And if you didn't care, you could just wild card the check and it would just always pass. It just creates sort of like a baseline, like there's a permission associated with using signers.
I don't know how I feel about it because I've always thought about the certificate as it's an identity. You should be making sure that just because someone has an identity does not grant them any authorization. So I think it should be easy to request certificates from any signer. And in most of the use cases I can think of, every pod in the cluster has like if you wanted to give them a spiffy cert, every pod in the cluster has a natural encoding of that. Like,
I mean, if you agreed how to encode your spiffy ID.
Rita brought up we have a time check. I think we should probably move on to other topics. I kind of agree with David. I don't really think a permission here makes sense. Maybe like we should think about how to prevent DOS abuse quota issues, but I don't know that I love the idea of doing authorization checks. We can finish the discussion offline, but we should move on.
All right, so yeah, please continue this maybe on Slack or get schedule one-offs, I guess. Next topic. Are you on the call?
Oh yeah, hey,
Okay, go for it.
hey folks. Yes, I started conversation around this last week, like a couple of weeks back. So basically, I think the proposal is to add request characteristics that can be used in cell expressions to help perform more complex validations in the authentication. So I think the last link would help the basic talk can help start this conversation on the problem statement and everything. So basically, I think the specific use case that we're trying to do is we have X59 certificates and certain components authenticated that X59 certificates, and then the Revit authenticated with OIDC. Just in an effort to reduce the blast radius, we want to restrict such authentications to certain request-based characteristics like IP, or only restrict version, URL, path, uh, for certain specific types of authentications. Technically, internally, we do it. If we want to do it, we can just do a patch. It's a single line patch saying that any request, whenever it's a certificate authenticator and it's not local network or something, just reject it. But I feel with this new authentication configuration, I guess we have a lot more flexibility. And in order to enhance it, believe we can add this uh, request characteristics. And I think the contention is mostly around what are the request characteristics that we can expose, and like how we can actually perform these validations on these request characteristics. So I just wanted to start a conversation around this and like have a work in progress so that we can work towards achieving this goal. I just want to hear your thoughts and everything on this call.
Yeah, first of all, thank you for jumping in. Nice to see you.
Yeah, introductions, I guess. Good to put a face on a name, I guess. So this is my first time ever doing these like SIG-Auth style meetings and everything. I'm
Yeah.
starting to get into these open source contributions and learning this whole process. I see there's a whole organization behind this with a whole management style and everything as well. So excited how this goes forward.
Organization might be overstating it, but welcome. glad to see you. So I mean, moving our authentication configuration into like a structured config format, that's a long-term goal, and we're sort of doing it piecemeal, where we end up having a million flags to configure everything, and having that be expressible in like a structured config that we can validate. Like that's just easier to understand and document and use. So what we have done for other areas like the JWT, OIDC stuff, and the anonymous stuff was first just bring in the ability to express those configurations in the config file identically to what we had for flags. And so if you were interested in expanding the options around certificate validation, I think that would be the first step. Like, what would it look like to just translate with exact parity the flags into the config file? So sort of having that as the first step. The second step, which was what we did with JWT and OIDC stuff, is what are attributes and validations specific to that domain that we could maybe make use of with cell. And so for JOTs, it was claims in the JOT. And so we said, here's how you map claims in the JOT to user info. And so if you were interested in exploring, proposing some of the things specific to certificates, that could be a possibility. We'd have to think about like whether we want to allow inconsistent mappings given how widely interpreted certificates are. And then the other piece was like validations on the resulting user. So after we've determined the shape of the user info, like thumbs up or thumbs down on it, I think that would actually be pretty straightforward to do. Like taking the standard mapping from certificates to user info, and then having an opportunity to run like validations on the resulting user. So neither of those expand the surface area. It's just a chance to sort of hook in, a thumbs up or thumbs down decision. And that would be consistent with what we've already done with JWT and OIDC. The next step, which is what you're describing, is like pulling in extra attributes from the request and making that be part of the authentication layer's decision. And that gets really twisty really quick. We've actually had several discussions about like exposing more request metadata, like network information and IP address and things like that, to the authentication layer. And there's just a lot more considerations around whether we even have that information and if it's trustworthy and what to do about it with it. So I wouldn't try to do all 4 of those things at the same time. But if you're interested in like adding more, ability to do cell checks on the resulting user that comes from a certificate, like that's the path I would follow. Like bring in the flags
that makes sense.
file
Yeah.
with parity, maybe add validation stuff after we do the user mapping, and then maybe look at expanding request metadata. But again, we've tried to do that before, and it kind of opened lots of cans of worms really quick.
That makes sense. I think what you mean is in JWT Authenticator today, we have like user validation rules. I think something similar for the 509 certificate would be the next step. You feel?
Yes, and right now the input to those validation rules is the user info. So like you don't have more stuff from the request, like the IP and the network and all that stuff. So
Yep.
if the surface area is constrained to just the user that was derived from the certificate, then being able to do validation rules on that with Cell the same way we do with OIDC stuff, like I hadn't thought about it a lot, but that seems like a fine thing to add after we pull it into the config.
Yeah, that sounds like a good starting point as well. I think we can extend for X509 certificate and add these user info validation rules. Let me start with that one, I guess, maybe in the next week or something, and I'll start posting on the Slack channel as well. And then maybe we can extend to going around making request-based validations as the next step.
Yeah, I don't want to overpromise. Getting it into the config file, I think, is useful. Having the ability to do some additional validation on the resulting user, I think, is useful. I'm not sure about the request IP stuff, so I don't want to overpromise.
Yeah, sounds good. Yep.
But thanks.
Anybody else
I
has any
wanted to
thoughts?
ask though. I've been it's been a little while since I'm actually blanking on the person's name, and I feel bad who presented the problem statement last time. But one of the things that wasn't clear to me is like, so I guess there's some desire to like I think the intention on EKS's part was that, hey, I have these X509 certs, but they're meant for like cluster local operations with some trusted agent or something that's gonna, and we just don't want that ever to leak out, right? But like I mean, I admit it's been like a couple of years since I used an EKS cluster, but I remember the last time I did that, like, for example, I think aggregated APIs work totally fine in that environment. So it does mean that you have like request header auth configured on those clusters, even if you're not using a request header proxy. So are you guys like patching that out to not work on the API server?
Sorry, I think I didn't get it. I'm not sure if I can answer that one enough as well. Don't understand that completely.
So you don't have to try to answer it now, but maybe dig into it, right? Like,
Yeah.
the request header authentication is direction. No, I know, David, you can configure it and not use it, but the point is that it's physically present, and therefore there is a key that can create arbitrary user infos against your API server, right? Because we have one knob that controls both directions, right?
Client certificate is not the same as request header proxy. So like a simple thing today that you might want to do is say, I have one client CA that I expect to only issue certs with usernames following a certain pattern. And I have a different CA that issues users with certs with a different pattern. And today, there's no way to be able to tell the server, like, I have 2 CAs I recognize, and I expect certs with usernames like in different buckets to come from those. Like you can't say that. But if you
Yeah,
could,
but that's not what
configure
I'm
it this
getting at,
way,
Jordan,
you could
right?
say I have one CA validator, and I expect the resulting username to have this pattern, and another CA validator with the username of that pattern. That's the kind of thing that this would let you partition that you can't do today. It's just one big ball of CA trust that you hope are well behaved in the certs they produce. And that doesn't
Right.
have anything to do with request header proxy. Like that's the Kube API server that you gave client CA roots to.
But again, though, I think you're missing the statement I'm making there, right? Is that if the problem statement is I am unsure about these credentials getting leaked and therefore being able to assert identities on my cluster, the request header is a big gaping hole in your IP-based security system that you're trying to make, right? Because you are trusting that private key to be able to issue a credential that can impersonate, or not impersonate, but create out of thin air arbitrary identities, right? So it doesn't matter that it's not a client CA. It is still a thing that can create identities against your API server. And it is configured always on all these clusters because they all support API aggregation, right? And so what I'm saying is that you can't fix this hole with IP-based restrictions without fixing the other hole also, because they both exist and they have the same failure mode, which is I lose one particularly important identity and I am hosed. It just happens to be one is the front proxy identity that can create arbitrary users versus the client CA identity, which is some arbitrary identity, but I assume it's also going to be cluster admin because it's going to be some privileged local agent doing privileged things, right? So like the problem is exactly the same, which is somehow you're saying you cannot protect these credentials enough.
Just
So
because
we
you're
protect the
running on the
credentials
same
and
machine, so you can use localhost, does not mean that you are running in the same file system or in the same process namespace. Those things are meaningful protections, Mo. And I do see a distinction between saying you're on the same host or you have network access via the same host and you are in the same process, you have the same SE Linux labels, and you can actually go out and read these files. I do see
but I'm not arguing against that, David. What I'm saying,
what that means
you
is
can't
that
do.
this gaping hole isn't equivalent in terms of accessibility. And that you could gain a lot of benefit by doing the network restriction that's being requested here. I'm not saying I think it's a great idea to rewire the authentication flow to include IP anyway, because trustworthiness of it I could see being questionable. But I'm also not going to rule it out as it's equivalent to something else, so we shouldn't worry about it.
No, I'm not saying that we shouldn't worry about it. I'm saying you have to do both.
yeah, so we have like restrictions on like getting the certificates signed, if that's what you mean. Like we don't allow certificates to be signed by like random agents or something. It's just like somebody just gets access to this. Like, let's say I have like a hybrid node setup, right? Like I have some custom controllers that is running on like some on-prem node, and that only authenticates with like certificate-based authentication. Somehow just gets access to that. But that on-prem, we have control over it through some IT mechanisms and stuff like that. But you get access to it, you're going outside the cluster, and you continue to use it. So
Yeah, I don't think that's what Mo's saying. He's saying that
oh, okay.
it completely separate from the certificate use issue that you're trying to solve.
Mm.
There is another authenticator that pulls user information from headers, and that like solving network use issues with certificates wouldn't do anything to change how that authenticator behaves. And that authenticator, if you're using it, lets you assert arbitrary identities if you have the trusted proxy key. So it's another thing to solve if you are trying to make sure that certain users can only come from certain networks.
Yeah,
So
that's not
something to be aware of.
Yeah, and you basically can't not have the request header configured if you want to be able to use API aggregation. I guess you could maybe re-implement all the controllers yourself and somehow try to fake it so the aggregate APIs maybe work. Actually, I'm not sure if that would work because I don't know if.
All right. We should probably time bound this as well. I think there are good next steps if you're looking to contribute to this, despite maybe not getting the IP validation you want.
It's okay. It's stage one. Let's start with
Yeah.
stage one and move there. Yeah. Thanks, folks. Yep.
Great, thank you. All right, let's move to the next one, Peter.
Yeah, so if you haven't met me before, I'm Peter. I work at Microsoft with Mo and Anish and Ben. And I recently watched the SIG-Auth discussion from April 9th on authentication of webhooks. And seems like something that everybody's interested in to some degree, and no one's opposed to the effort. But no one seemed to have the cycles for it at the time. Mo has asked me to start looking into it, and it seems like the next action that was set out at the end of the last discussion was for someone to put together a doc, kind of summarizing and synthesizing the existing discussion around the issue, because there have been two KEPs that have kind of failed to progress. Off the top of my head, it's 2510 and 658, and significant amount of discussion around that. So I just wanted, before I go ahead and put together that doc, I just want to confirm that people are interested in this effort, and in addition, just like gather any requirements that you would have for the document itself. Like, what do we want to see in this document that would make it useful to us? So I'll pause there for any questions or thoughts.
I'm trying to page this back in. What you described sounds about right. Like, there was interest in it. This was the thing that would be useful if we had it. The previous attempts, if I remember correctly, had some pretty fundamental flaws, like putting credentials into the API or assuming that Kube API server was the only one that would need to get and use these credentials. So a proposal that sort of summarizes past attempts and proposes a way forward that addresses those, I would welcome.
Okay, so one vote for please do this. Is anyone, I mean, does anyone, if no one's opposed to it, as far as I can tell. So summarizing the past examples, or past attempts, and I guess the challenges in particular that those efforts met.
I mean, the things off the top of my head were like, we're not going to put reusable credentials visibly in the API, and we're going to come up with something that plausibly works with all the things that need to call these webhooks, which is not just Kube API server.
Yeah, if I remember correctly, there's aggregated API servers, and another concern that was expressed is like, well, a couple things. We want to make it essentially make a easy path, to make it easy for people to retrofit existing webhooks to do this kind of authentication, so that people actually use it, and also make it hard to do the wrong thing. And then in addition, there's some approaches that work well, don't work well in external webhooks versus in cluster webhooks. And so my understanding is that the design needs to fit both use cases. But,
yeah, I don't know that we have to solve all of the problems at once, but we should at least
right.
survey what the things are, and
survey what they are.
If the solution only addresses internal webhooks, or we should understand what it is we're solving for, even if we do it incrementally. The landscape has evolved in the last 5 years as well. So we have ephemeral tokens, we have audience scoped tokens, we have more certificate-ish things that are available to us now. So I think when we talked in April, we were just saying we should at least look at what we have available and, you know, pros and cons of using each, and just if we propose a particular solution, like how it compares to if we, you know, chose certificates instead of tokens, or vice versa.
Okay.
All right, next topic, Peter.
Also me. So I've been working on the allow list for Client Go credential plugins. And Jordan, you brought this up last time, that the allow list, by, you know, it prevents essentially untrusted binaries from being run in the process of getting credentials. Those binaries are configured in the kubeconfig, and kubeconfigs are often generated, so a user might not know off the top, like when they get their generated kubeconfig, like what binary it's telling you to execute, and it could be malicious. What you brought up last time was that the kubectl might not be the right place for that configuration because that's a kubectl specific configuration file, and then only kubectl benefits from the allow list. And so I'm trying to understand what the alternatives are. Like, can we, you know, have the allow list kind of check exist in client Go, and if that's the case, you know, how's that configured? Can we have other clients other than kubectl also parse the kubectl, because many of them parse the kubeconfig already? And then if we do end up moving it into client Go, then, you know, Go clients essentially can benefit from it, but not clients written in other languages. So just trying to get people's thoughts on those various issues to try and move this forward, because I have a, you know, I have a working implementation. It's just a matter of where does it live and who can use it.
The ability to set the allowed binaries living in client Go, I think makes sense. So if I'm driving creation of a client programmatically, you know, if you open up any of the client Go examples, they all basically say point at a kubeconfig file and slurp it in and build, you know, a REST config and build a client. And so anyone copying our client Go examples is exposed to their binary, you know, pulling in a kubeconfig that says invoke this other binary over here as whatever your user you happen to be running as. Making it possible for someone who is programmatically constructing clients in client Go to say, here's the binaries I'm okay running, and maybe that's none. So having the mechanism that says, here's the allow list, or the function that says, you know, is this binary okay, thumbs up, thumbs down, error, like whatever the mechanism is, having that live in client Go, I think is a good idea. So that, and then kubecontrol can use that mechanism with an allow list that it loaded from kubectl, for example. Whether we want there to be a well-known file that lots of tools read from and use as the allow list, I'm not sure. I'm less opinionated about that. But wherever kubecontrol gets its allow list, if it's kubectl, okay. But then the way it enforces that, I think, should be to set the, you know, gating allow list function into client Go in some way.
Okay, so to summarize, the gating check lives in client Go. Creators of clients can use it at the time that they create the client. So, for example, someone creating a client by loading a kubeconfig would provide both the kubeconfig and an optional allow list. The allow list is provided. Let's say kubeconfig is invalid according to this allow list. Is that
something along those lines?
like that? Okay.
Yeah, I hadn't dug into a lot of the details as much as you had because you've been there implementing stuff.
Right. Yeah.
But I mean, if the goal is to protect at a process level, risks of like calling out to binaries with current process user permissions, something like a global process wide like gate, or not gate, but check of whether invoking a binary as a credential plugin is allowed. Normally we hate globals. If the risk is I'm going to load a kubeconfig in some way and it's going to inherit my process's user permissions, maybe and there's an implicit global like thumbs up, do whatever you want today, maybe the ability to control at the process level, set my credential plugin allow list. That might be okay. We've done similar things for like process level warning handling for client Go, because you can create clients a million different ways and they encounter warnings. Like kube control does that when you start up to say any warnings my clients encounter, I want to dedupe and print out to like the command line with color highlighting. So we've used hooks like that in the past, and it's been okay.
Okay. And I suppose the answer to the question, like why make this only, available to Go, I suppose anyone can implement it themselves. The logic's not that complicated.
I actually
and
don't
they
know
can-
if we implemented exec client stuff in the other languages. Like anything else
It exists in a bunch of them, not all of them, but like JavaScript even has it, which is kind of weird.
Yeah. So I mean, a similar mechanism to be able to say what are the allowed binaries for like that doesn't actually seem that hard to do or to wire in at the point where those other exec plugin implementations are like doing the call out. They consume the kubeconfig. It says, oh, you wanted to use exec plugins, and right now they're just doing like an OS exec or whatever. Like, especially if it's wired up as a check if the person who's running this binary has an allow list, and if not, do what you're doing today. And if they did have an allow list, is this in that list before you invoke it? Like that seems like a pretty surgical way to let the process or the binary owner like protect themselves or have a default deny or something.
Okay.
Jordan, so I assume though that you're not expecting this to change the REST config, right?
No.
Right.
I'd expected to wire in super low level, the point where like you're about to call the binary to get the credential.
You want the enforcement right before like execution, basically.
I think so.
So how are you going to flow it through there? So like other than the global, how would you flow it through there? Because it has to then go through transport config, which goes up to REST config, none of which seem remotely appropriate for this type of stuff, right? Because it's like, hey, I configured an exec plugin and I don't want to use it. Like, what? So to me, either it has to happen before the construction of a REST config, like in whatever, like deferred client loading, whatever in client CMD or something, whatever those things are called. They have really long Java-esque names.
We could do it at validation time. The problem we ran into with kube control is kube control commands that don't even make use of the client where like,
Yeah, that's the
Go ahead.
issue that's come up so far is, yeah, kubectl config view is getting short circuited if you do it too
like,
high up the
your
stack.
config is invalid. It's like, all right, fine. What is my config? Kube control config view. It's like, your config is invalid. Like, I know it is. I'm trying to see what it is.
This seems totally in line with the rest of the project.
Yeah, point of use, like, if the goal is to be like a backstop, so we don't invoke a thing you didn't want, like, point of use accomplishes that. It doesn't make for a great experience if you're trying to like validate ahead of time that I've got a config that when I make calls, it's going to do what I want. But it does accomplish the backstop, like, don't invoke a binary I didn't say you could.
Okay, would it be terrible if this got implemented like in the loading logic, but then set as like a transport wrapper?
I don't know.
At least then kubectl config view would work because it would never run the round tripper.
There are so many kube control commands that construct but don't use clients. Like every create, dry run, and every
Right, that's what I mean. So as long as you don't actually directly try to round trip, it won't fail.
Yeah, that's what I'm saying. Like, point of use. I hadn't dug into like what the cleanest way to do it at point of use would be.
Yeah, I just don't want to try to actually change the exec authenticator because the only way to do that is to then funnel new fields through every configuration struct that leads to it, which sounds awful. Or a global, which also sounds awful.
Yeah. Can we? Does this give you a direction, Peter?
Sure, and it gives me plenty of stuff to look into, at least ponder, think about. Thank you.
Right. Can we get to the last item? That's been on the agenda a few times, and I'd like to.
Yeah, I think Min's on the call.
It'd be nice to wrap this up.
Yeah. Hey, can you hear me?
Yeah.
Yes.
Oh, nice. Yeah. I mean, I work in the community many years ago with David and Daniel before, and disconnected for.
Sorry, it might be me, but it's kind of hard to hear you.
Oh, really? How about now? If I talk louder, does it help?
That's better. Yeah.
Yeah.
Okay.
Louder helps. Yeah.
Okay. Yeah, sure. So I'm from EKS, and I work in SIG-Auth machinery before, and the topic I want to talk about is revisit the design of KMS v2 cache we have in the API server. Inside EKS, for the context, we're using we're enabling the encryption for all the objects inside EKS clusters. And right now, we saw two issues. One concerns the availability, because we saw that right now we're using an expiring cache for saving the DAC content. But that leaves an issue when the DAC expires, and somehow, let's say that our KMS cloud service isn't available for whatever reason, and during that time, our cluster will shortly become unavailable. That's something I think that's totally avoidable if we use LRU cache, and a cache that doesn't have expiring time. That's something I majorly hope to discuss. And there's another issue we observe with this KMS that cache is the scalability issue. Right now, I linked a PR at the end of my agenda. So essentially, we're seeing that right now the memory consumption from this cache can grow unboundedly if there are intensive cluster writes onto this onto this cluster, because every time when there's a write operation, we're inserting an entry inside a heap, like a heap construct inside the KMS v2 cache, and that cache is not that heap is not like GC'd until let's say until the time expires. So that's a issue we saw, like in some of our EKS clusters. The memory just grows up monotonically, linearly. So based on that two issues, I hope to hear what's your opinion about refactoring this cache to just a non-expiring RU cache. Does that make sense?
So one of the PRs that's linked is to improve the performance of the expiring cache,
Right.
which I assume we can ignore if you just don't want to use an expiring cache at all.
Yeah, yeah. Right.
Okay.
That's correct. I think if I try to understand the history why we're using expiring cache at the beginning, it looks like something unintended. It's like a random like legacy historical code, if I understand correctly. Or is there any particular reason why we're still sticking with the expiring cache here? I think we have some data here. So as I said, most of the EKS cluster has is encrypting with the KMS v2 right now with the KDF feature enabled. So the largest, even for very large clusters, the cardinality for this DAC cache is just around 20-ish. So I don't see the need for using an expiring cache, and I hardly see the chance when this when it can exceed the size limit for our cache. That even if we say that the cache size limit is 1,000, I don't see the chance how it can hit the limit.
Explain to me which part is causing that memory leak effectively, though. Like, so it's got a 24-hour TTL, right? But you're saying that you only have 20 entries, so why does it matter?
Well, the cache size is not the part having the memory leak. It's another like internal construct. It's a heap struct inside this expiring cache. If we so if you take a look at the PR I linked at the bottom, so that's something it's trying to solve it. So essentially every time when we're inserting update or like updating an entry inside a expiring cache, it will always insert an entry into that heap construct. That heap is for tracking the expiring time I think it's a minimal heap. It's for just for popping out the most stale object from inside the cache and trying to see which decide stale object we should delete.
So we have a bug in our existing implementation.
Right.
And the fact that it's expiring is saving us from making that bug problematic. If we made it non-expiring, that existing bug would turn into a memory leak.
Right.
Yeah, I mean, but the TTL is a day, so it is going to grow for a whole day before it catches back up, which is not super great.
I mean,
It's
fixing the bug seems fine. If we like in my memory, the reason for the expiration was because we didn't know a good max size, and so we, in the case of sustained create delete create delete create delete, we wanted to garbage collect. That may be moot after the switch to the KDF.
No, even with the KDF, you can have problems if you're just constantly rotating key IDs. Like there's no limit on how quickly you can do that, so you can just keep like that's why it has a 24-hour TTL to just be like, okay, it'll probably work.
Rather than making all entries expire automatically, it wouldn't bother me to make the thing we do once every 24 hours be to drop the oldest entries if we're over a certain size. Like I would be
cache that doesn't exist today, right?
Yes, it's a different cache that doesn't exist. I'm
You
sympathetic
didn't
to
want to write another cache. There's like 3 things.
We're also over time. Fixing the memory leak issue. If we have a memory leak issue, I'm philosophically okay with fixing that. Making it so
I guess if the expiring PR fix merges, does that fix the KMS bug just innately because it just fixes the cache and then we don't need to worry about it? Yes, you still have some theoretical like outage concerns after a day where things expire. But ignoring that, like, does it at least fix the memory leak?
Yeah, it fixes memory leak, but there's another issue. The first issue I mentioned regarding its availability, because when let's say the KMS service is not available when the key just expired after 1 day, and during that time the cluster will just keep failing.
I mean, it'll fail writes, it won't fail reads.
Not fail writes. Yeah, that's right.
But yeah, I mean, I guess if you lose enough of the cache quickly enough, then I guess the whole thing will blow up.
Folks,
We're out of time.
Yeah, so Min, do you mind keep discussing this either in the PR or on Slack?
Yeah, sure.
Thank you. Thank you, everybody.
Thank you.